Hello everybody, in this video I will show you how to use software I developed in order to compare graphs taken from the 4185A or any other instrument and put them side by side in an HTML page and view them, compare them, share them, whatever you want to do. Let's get started. I'd like to show you quickly how to get the software up and running, and then I will get into some details. But first of all, let's see what the software can do. Okay, ready? Here we go. Alright, this is my 4185A. I have it connected to an outside antenna right now. So let's take a spectrum. Okay, as you can see, I have a start frequency of 90 megahertz through 110 megahertz. Video filter is on. Auto scale is on. And port select, I have R2. Okay, as you can see that this, I am definitely reading something. Well, I'm reading FM radio band currently. Okay, so the 4185 is ready to go. Let's go over to our computer and have a look at the software. Okay, so we saw what the 4185A shows. So let's get that into our webpage so we can start doing some comparisons, okay? So first of all, the software I have in OPT GPAB code, as you can see, and the software also is updated on GitHub, and the latest is there. You will see that I have a quick how-to PDF, and you can read that, but more importantly, this video will go over all the steps. Let's not waste any time. Let's get started. There we go. Okay, so basically here I'm saying create a plot. This is the first, number one right there. I will put this in this directory, sample spectrum test 1, which will be the directory in the Apache folder where all the scans and the graphs and everything else will be in there. The name of this run will be first run of spectrum test, and the name of this project, which will be test to check functionality of spectrum analyzer. Okay, the name of this project, test to run functionality of spectrum analyzer, blah blah, is only specified once, and then after that we just change the name of the each run. All right, let's do it. As you can see, the program tells you where the temporary files are kept, because afterwards you can look at them. It tells you the IP address of the Prologix GPIB to Ethernet controller, the GPIB instrument address for the 4185A, which is 3, and in the end it gives you things like what it read from the instrument itself. Okay, and that's pretty much it. Nothing changes in this directory. Everything is in the temp GPAB build, and let's have a look at that. There's a bunch of stuff in there, and the actual output goes here, which is var www html is my Apache directory, which is the document directory, and further GPAB scans is where all the scans will go. As you can see, sample spectrum test 1 is the directory specified in the command line, and if I go in there, there's a bunch of other files. Okay, so let's see what our HTML page looks like. Okay, so you see that on our web page we have the main description above, which is Athena, which is the name of my machine, and the title is Instrument Scans. Okay, there's a time and a date underneath there, and underneath that you'll see that we have this description of this project, which is test to check functionality of spectrum analyzer, just as we did on the command line. Okay, so let's click on that, and there it is. I have from 90 megahertz to 110 megahertz, which is what the spectrum analyzer sees. And of course you're going to see underneath a phase diagram. And for spectrum analyzer, phase, what does phase mean? Phase means nothing. And we're able to see. So if we click side by side from up here, there we see the power graph and the phase graph right there, side by side. Alright, so why don't we change our spectrum analyzer a little bit and see if we can compare the graphs. Okay, here we go. Alright, so I changed the 4195A to scan from 90 megahertz to 220 megahertz. So let's take a snapshot of that. Alright. Now we don't need the description of the project because we already started a project. Let's call this second run of spectrum test. Sample spectrum test 1, that always remains the same because that's the directory where the Apache reads the HTML code from, but this is run number 2. So let's run that. My mistake. The stop frequency is 240 megahertz. Okay. And there it goes. All right. Now let's see what our HTML page looks like. Okay. Again, starting from home, we have the project names right there. Okay. So let's click on that. Now we see that we have 2 power graphs, one on top, one that we just created. The most recent one always goes on top, which is from 90 megahertz to 240 megahertz, and it's also shown up here on the description right on top of the first graph. And then we have the second graph right underneath it, and then we have the 2 phase diagrams. Okay, so let's look at this. This is not continuous. This is first the power graphs and then we have the phase graphs. Okay, let's look at it side by side. Okay, there you go. All right, now this is really, we can see that first of all, in the beginning, we had our frequency was from 90 to 110. As you can see it right now, as I move through the graph, it shows where my mouse is. Okay, so as you can see over here, that was 110, right? So you can see that this area over here is this graph down here, but then we expanded it to include the up to 240 megahertz, which includes actually the ham radio bands as well. and there's also a lot of stuff going on in here. Okay, this is how you create quickly some graphs and display them. Now we're gonna do something a little bit more sophisticated, which is we're gonna compare a filter, okay, and we're gonna see what the filter looks like and its response, and we're gonna compare that with what the manufacturer says. All right, so let's have a look at that. Okay, so let's take some measurements, some S parameter measurements, and let's compare those. First of all, I'm going to take S21, and the first thing I'm going to have to do is calibrate my 4195A. All right, so let's go to S parameter, S21, and then let's set up the start and stop frequencies. Let's say start 380 megahertz, and do a stop 485 megahertz. There we go. Now we need to calibrate. So calibrate, S parameter test menu, normalize and isolation. Okay, let's do that. We need to do that. Normalize the calibration. Through, I'm using my extremely low loss cable for that. Set that guy up over here. Okay. Check. Let's go to isolation. Isolation for the 4195A requires that you use a 50 ohm terminator on the output of the generator right here. And let's do that. Okay. Turn calibration on. Okay. When that happens, the triggering goes to manual. So let's set trigger to continuous mode. There we go. And finally, let's set up our little filter. Okay. Here it is. There's a little filter right here. Okay, this is the in, RF in, this is the out. So we're going to plug the RF in to the RF in right here, and like that over there. Hey, look at that. All right, let's look at the power, or rather the frequency response. First, let's take out the phase graph for now. Okay, so let's go to trace B off and go reference and auto scale A. Okay, let's set up all of the video filter. Okay, and it is continuous mode, right? Okay, so now let's look at our phase menu. Display, trace B on, trace A off, and auto scale. Not much of a difference there, right? Wait a minute. Sorry. Now I can do B auto scale. There we go. Okay. Right, so let's show both A and B and turn the B off for now. We will show both phase and power on our display, but for now this is what that looks like. Okay, let's go over to our command line. Okay, so now that we got the 4195A set up, let's read from the instrument and put the data on our web page. Okay, so let's start. So this is the first scan. Let's call this filter response. Let's call this data from the 4195A, and the project, let's call it filter with manufacturer data. Yeah, that's the proper name. Filter response from 4195A and manufacturer data. Okay, capitalize that. Capitalize that. All right, let's run it. Okay, now let's see what it looks like in our web page. Alright, so as you can see, the HTML page is showing our new project, filter response from 4195A and manufacturer data. This is our previous project over here. The new project always shows up on top, so we had like 20 projects here. This would be like right on top. Okay, so let's click on it and see what we have. There you go. All right, there it is. Let's look at it side by side. Okay. As you can see from the phase response, it kind of looks good until about right over here. What is that? 438 megahertz, which is interesting. Okay, so over here the middle is 430. All right. Okay, so let's add the manufacturer provided filter response. Okay, let's do that. So we have the manufacturer provided graph of what the response of the filter is. So let's see that. This is what I got from the person who sold me this filter on eBay. Okay. So I am going to run this command now, which is import power -p. And actually, if you do a -h on plot copy XA -h, it will give you all the appropriate options. So you could import power or phase one or the other. You don't have to specify both. You could specify one or the other, and the web page will be updated accordingly. Okay, so let's run this baby. This actually runs very, very fast, and the options here -p, which is the actual PNG file that I have. This is run number 2. Filter response always remains the same because, again, this is the filter response directory where Apache will read the data from, and the run description, which is data from manufacturer. Let's run that, and there you go. Now let's have a look at our HTML page. Okay, again from the home page we see that the project is still filter response. The project name is filter response for 4195A manufacturer data. Alright, so let's click on that. Oh, there we go. So this is the graph up here as was provided to me of this filter response, and below is what we read from the 4195A, and the description up here is pretty detailed and exactly where this data came from. Okay, let's go side by side. Okay, as you can see, the phase data is missing, so there's nothing there. If I had provided response, if I had provided phase instead of response, it would have shown something here and nothing over here on the left. It depends. You could like I said, you could specify one or both. Okay, so over here, the plot that was provided to me says center frequency is 433. So if we go over here, down here, we go 433 right here, 433.920 on top, 433.8 over here. Okay, as you can see, the two graphs are pretty close. I mean, I could have changed the resolution bandwidth to something even smaller. You know, that would have taken forever to finish, of course. But you know, you can see that the graph on top, the VNA on top, is a smaller resolution bandwidth, which is fine. But they do correspond. Okay, the top. I mean, they are a little bit shifted over, but the point is that the center frequency is, you know, over here and on top. Okay, so the phase response, as you can see, from 426 to about 438, which in this case would be 422, 424, from about here. About over here. .440 is right there. Okay, as you can see, the phase response is pretty smooth in that area, which is important that the filter this was what the manufacturer specified that the filter parameters were. This was the area. Okay. Now, like I said, if you wanted to see the GPIB source code at GitHub, you can click here. There you go. All right. Also, the ProLogic GPIB Internet project is also in GitHub. Yeah, you would need that. I have all of that in the how-to document I provided with the software. So if you read that, you could click on all this. If you first thing you should do is read the quick how-to, and that will get you going. The quick how-to PDF, that will get you going. Then make sure that your instrument is set up properly. Well, here, if I can just quickly do that right there. There is a configuration file where you configure the IP address of the ProLogics and the GPIB instrument address. All of that is in the how-to, okay? So download the software, read the how-to, install all the modules, Python modules, and see and get started and start comparing and use this beautiful instrument. 4195A is just amazing. It's an amazing instrument. Okay, so that's what I have for you guys. You know, if you like this, please click on like. Everybody says click, smash the like button. Whatever you want to smash it, you want to click it, whatever you want. All right, so thank you very, very much for staying with me in this. It's been like, I don't know, 20 minutes or something like that, 25 minutes. Thank you very much for watching. I hope you enjoyed everything. There's my contact info is, you could send me a message through YouTube. You could look at the project. I have my contact info in the project in GitHub. I'm also on a couple of HP lists, and you could reach me in there. I will accept all requests for additional features. I have a few in mind myself. So, you know, this is just the project to get things started, and that's exactly where I want it to be. Thank you very much, everyone, for watching.